Okay, so I'm gonna do this while I'm a bit sick. But I'll just try to do it quickly, and I'm on low battery anyway, so I'm gonna do this as fast as I possibly can. So this is the AP Precal 2.1, 2.2, the notes for the quiz and whatnot. So I'm just gonna go ahead and start. So the first one says that let A be an arithmetic sequence with certain values that it gives us, and it wants an expression, and to use the expression to find A of 20. So we know that the expression is just A of n is just A of k plus d, which is the obviously common difference, and then n minus k. That's our basic one, and let's see what it gives us, because first we obviously know that we're going to need this value, this common difference, and it gives us ones that we can find. So it's just like a slope formula. You know, the common difference is just going to be a6 minus a2 over the value. So it's going to be a6 minus a2 over those values, which is just going to be a6 is 9. Sorry, hold on. No, sorry. Okay, so those are your y values, right? Which we have. And a6 is the sixth term minus the second. So that's just a6 is just 9 minus a2, which is 8. And then you put those over the value. 6 minus 2 is 4. So when you just compute that, that's going to give you that the d value, common difference, is 1/4. Okay, so d is 1/4. Now let's get the other ones. An is just going to stay because that's what we're solving for. AK is just a term. So let's go ahead and use this one. So we know that AK is just going to be, we can call it 8. Let's just call it 8. And we know that the corresponding value to n is, to k is going to be 2. Okay, because that's the one we have. A2 is 8. So let's try to put that. So we have and actually, I'm just going to erase it and write it all. I'm just going to fill in the terms that we have. And that'll be our expression. So a of n is just 8. Obviously, that's our k plus our common difference, 1/4, n, and then minus, well, it's the second term is k, 8. So that's our expression that we have. So we've done half of it. Now we just need the expression to find A of 20. So we just plug in the values. A of 20 is 8 plus 1/4. N is obviously 20 minus 2. So that's just 8 plus 1/4, 18, which is just, that's just going to be 18 over 4, and 8 is 32 over 4. Which is going to give us 50 over 4, or 25 over 2. And that is A of 20. So we just got A of 20. And we have the expression. And that is it for the first problem. Let's move on. Okay, so that was an arithmetic sequence. So now we're going to move on to geometric sequences. And they have a different equation, so let's just do it. So it gives us these values. It wants an expression for g formula and use the expression to find g. So basically the same thing. The original expression is just g of n is g of k, our r value, and n minus k. So let's plug it in with the values we have. We have r, and we have k, because it gives us 1. So what we can do, we can write it as g of n is, let's use g of 1. So our k is going to be 12, g of k is 12. We have our r, and we have our k, which is 1. So it's going to be n minus 1. So we have the expression. Now we just need to use g of 4. Let's plug it in. So g of 4 is 12, 2, 4, minus 1, which is just the same thing as 2 to the power of 3, which is 8. So we have 12 times 8, which is just 96 So that's g of 4. G of 4 is 96. Okay, so we solve that. Go to the second one. The next one. Okay, so it says g of n be a geometric sequence with these two values. It wants us to find an expression for g of n. Okay, it's not that hard. So what we first need to figure out, right, is, let's just do the expression, I guess, first. It only wants us the expression, so g of n is g of 3, which we're going to use here, I guess, as our a of k value. We need the r value. That's why we're going to leave it as a variable in this case. And then n minus k, which is 3. So that's just going to, g of n is just going to be -2 r value, which is what we're wanting to find. And n is obviously 3, so 3, or sorry, in this case, forgive me, what the thing is that we're trying to isolate r, so we can't have g of n as a variable because we don't want 2. So what we're going to do is we're going to use g of 3 as our a of k value, and we're going to use g of 6 as a value that we know, set it up as an equation, so -2r. And we know that's the sixth term, right? 6, so we can just do 6 minus 3. And then we do that, it's going to be r to the third, and so it's just going to give us 128 equals -2 r to the third. Divide both sides by -2, we just have r to the third is -64, or r is just, we want to cube root both sides. We're just going to get that r is -4. So what we have is we have all the values that we need. Now we can just go back and actually write the g of n expression. It's just going to be -2, we'll use g of 3, so -2, r is -4, and then n minus g of k, which is k is 3. So that is our expression. Great. Now we're going to go on to summations. In case you haven't noticed, we did arithmetic sequences, we did geometric sequences. Now we're still in 2.1, but these are going to be just summations, which shouldn't be that hard. So this one asks, this is the actual equation, I guess, is k squared, and we're going to go from k of 3 all the way to k of 7, and we're going to add those values. So we're going to plug in 3 into k, so 3k squared, we're going to add, now we're going to do 4 squared, 5 squared, 6 squared, 7 squared. Out of those values, that's just going to be 9, 16, 25, 36, 49. So that is 135. That's the value. So easy summation, that was just that. This one's going to be a little stranger because it's more of a complex equation. But we're still substituting k. So k, this will be 3 of 2 minus 1 plus 3 of 3 minus 1 plus 3 of 4 minus 1 plus 3 of 5 minus 1. That simplifies out to, that 6 minus 1 is 5, 9 minus 1 is 8, 12 minus 1 is 11, 15 minus 1 is 14. So that just gets us to 38, and that is the summation. Okay, so summation's not hard. So I don't know why that one is so small. Okay, so we're just going to do geometric sequences. I think I included the equation. I don't know why, because it might be like hard to remember, but there are a lot of equations where I just didn't include them, but you should still look over them, make sure you have them memorized and whatnot. So there's the two ways that they function. We know that there's converging and there's diverging. We know the restrictions that if you have an arithmetic sequence and it's infinite, then they never converge. So you can just go right hand right, diverges. And if we have a geometric sequence, they only converge if they have if the r value, if the absolute value of the r value is less than 1, then you know that they converge, right? And you'll be able to solve them a different way, but that's not going to be tested, so there's no point in doing it. So let's see this one. So this is just 10 plus 9 plus 8. That's obviously an arithmetic sequence. You're decreasing by 1 every single time. So we can just simply write diverges because it's an arithmetic sequence. So this one, you can see that it's not an arithmetic sequence. It is a geometric sequence. You can kind of decipher that. And I'm on 1%, so I'm going to quickly finish this up. So you know that the R value is negative 1/3. So positive that is just going to be 1/3 absolute value, and that's less than 1. So this one is an actual, this one actually converges. And I guess it wants us to evaluate either way. So all you have to do is just, you're gonna plug in a value for k, which is just 1, so it's gonna be 4,374, and that's to the power of that value, and that's obviously gonna be on the bottom because it's gonna be raised to that. So we just have 1 minus negative 1/3 right here, because it's a value that you have. That's just gonna be just 1 plus 1/3, which is 4 over 3. 4,374, 4 over 3. It's just going to give you, if you simplify it out and whatnot, 6,561 over 2. And that's, since it's geometric, R is less than 1, and that's the value. This one, okay, let's see here. Yeah, that's geometric, but look at that, 4 over 3. Absolute value of that is greater than 1, so it diverges. Can't really do anything with that. So this one right here, the last one, it's an application problem. Word problem, application problem, whatever you call it. So it says that across the United States, there are approximately 45,000 flights each day. In a certain simulation, total number of flights begun n hours since midnight. So, 1 is just going to be like this. I feel like this one, it actually wants to know if you know stuff about adding time, because it's going to be weird, because when you do this at 6 p.m., the n value is what is that, 1, 2, I think it's 18, which is weird because they're basically also testing if you know how many hours after it is. It's strange, but it's whatever. So let me just fix something right here in my key to make sure I actually do it right, and I'm not giving false information. Let me see here. Okay. And okay, here we go. So what it's saying is that there's 45,000 each day, simulation n hours since midnight. Model using arithmetic sequence. So we want to, give us an arithmetic sequence, but we need points for that. So if we're 12 is represented by n of 0. Yeah, we got that. Total number of flights that had begun by 5 was 11,750. Okay. And by 5 a.m. and by 11 a.m. there were that many. So it's asking how many total flights. So let's just give out our values that we have. We have f of 5, because that's 5 a.m., it's 5 hours after, and we also have f of 11, which is 22,250, and then we have, we can add as whatever. It's a function of n because n hours, that's your x values. We can call it f of n. And we need a k value for an arithmetic sequence. Let's just use f of 5. So we have 11,750. And what we want to know is we want to solve for the common difference since it's an arithmetic function. So we only want one variable. That variable, we'll call it d or r or whatever. But let's just use this one since we already know. Okay, so we're going to do 22,250. And let's use this as our k, a of k. 11,750 plus that d value, of course, and then n. What we could do is n minus 5, but this is going to be n, and we know that n is the 11th term. So we're going to 11 minus 5, that's k, and that's k. So you simplify that out, that's going to get you, subtract this side, do this, and it's going to give you 10,500 equals 6d, because 11 minus 5, 6. Okay, and then you divide that, you're going to get that your common difference is 1750, and I want you to know how many total flights have you done by 6 p.m. Like I said, 6 p.m. is 18 hours after 11, so you just plug that in, 18, and then we use our initial equation that we just did, 750, plus our d value, which we found is 1750, and then our n is what we're solving for, which is 18, minus our k, which this is our 5th term, so 5. That's going to give you, if you just do that, it's going to give you 34,500 flights by 6 p.m. And that is it. That's a whole lesson, or that's a whole review for the quiz. Should still want to study, but that's pretty much it. So, bye.